Alright, today we're looking at applying growth and decay. So we're going to see why we have this exponential growth and decay thing. There are two equations, you just need to memorize them, they're not given to you, about growth and decay. This first one is going to be when we're talking about money compounded. So this is going to be our compounded money. So if your problem talks about money being compounded, then you're going to use this equation. A stands for the amount afterwards, so your final amount. P stands for principal. Principal is what you put in, so how much you put in. Or your starting value. 1 is just the number 1 because that stands for our 100%. Rate is your percent as a decimal. Okay, so R stands for rate, which is your percent. You want to write it as a decimal. N, which is here, and it's also here, is the number of times compounded per year. Okay, so it's the number of times compounded per year. If it says it's compounded monthly, then you'd have 12 times per year. If it was quarterly, that'd be 4 times a year. Semi-annually, that would be 2 times per year. Daily would be 365, so on and so forth. You get the idea. T is the time in years. Okay, so anytime you have a money equation that's talking about things being compounded, money being compounded, then you're going to use that equation, and that's what those variables stand for. So let's actually do a problem based off of that. So let's come down here. And we've got $550 is deposited in an account that pays 3.5% annual interest compounded monthly. What is the balance after 7 years? So I'm going to see if we can fit all of this in here. So we're going to look at our equation. P equals, just kidding, A equals P1 plus R over N to the NT. A is how much, A is your final amount. That's what we're looking for. P is how much, whoops, my pen just broke. P is how much you put in, or your principal, your initial amount. So in our situation, we're going to hope this works. In our situation, P would be $550. That's how much we deposited, how much we put in. It pays 3.5% annual interest. That's our rate, but we have to write it as a decimal. So we're going to move our decimal 2 places. So 0.035 is going to be our R value. N is the number of times per year that it's compounded, so it's compounded monthly. So we know that N is going to equal 12. And T is the balance, how many years, so T is going to equal 7, because we have 7 years. So all we're going to do is plug this straight in. We don't know A. P is 550. Then we have 1 plus 0.035, that's our R, over 12, because we're compounded monthly. We're going to raise that to the 12 times 7, because 12 is our N, 7 is our number of times per year. I'm going to zoom in for you, now that we have all this information. And we're literally going to type this straight into our calculator as is. Don't worry trying to do 15 different steps. It's not going to be very pretty for you. So let me scooch this over. So we want to know what A is, so we're going to type all this in. 550 parenthesis 1 plus 0.035 divided by 12. Your calculator knows to do the 0.035 divided by 12 first, then add the 1. If you want to put parentheses around that part, that's fine, but just know that you're going to have to double close your parenthesis here. We're going to raise that to the 12 times 7. Okay, because we've got 12 times 7. Hit enter, and there's your answer. Now, you want to go back and make sure you typed everything in correctly, so make sure all your numbers match up. 550, 1 plus 0.035 divided by 12 to the 12 times 7. You can scroll up and scroll over if you'd like to check that. So we're all good. So our answer here is we would have $702.44 would be how much money we had after 7 years. So the money we deposited in, we put in $550 by us doing nothing. 7 years later, we now have $702. Okay, so another one similar to this is how much must be deposited now in an account paying 8% interest compounded quarterly to have a balance of $2,200 after 5 years. Let me try a new pen. So now we want to know how much must be deposited now. So now we don't know what P is. We've got 8% interest, so R is equal to 0.08. We move that decimal 2 places. Compounded quarterly, so N would be 4 times a year. We want a final balance. This is our final balance. So A is going to equal 2,200 and 5 years, so T is equal to 5. So we're going to plug in everything we know to our equation. So 2,200 equals, we don't know how much we're going to put in. That's what we want to try and find. We know we want $2,200. We know all these other things. So we're going to see how much do I need to deposit now. So P, we've got 1 plus 0.08 divided by 4 raised to the 4 times 5. Now in this situation, we may need to simplify a little bit. It just kind of depends on how you want to go about doing this. I'm going to go ahead and simplify on this problem just to show you the idea. So we've got 2,200. We need to divide by all of this stuff in order to get P by itself. We can't go piece by piece in here because this exponent is trapping everything inside. So if you want to look at it step by step, then we're going to look at what's inside the parentheses. So we're going to go 1 plus 0.08 divided by 4. That gives me 1.02. So we'll have P times 1.02 raised to the 4 times 5 is 20. Now you could do 1.02 raised to the 20th power. That's going to be a really hard number to type into our calculator or to write down on our paper. So what I'm going to do is I'm just going to show that I'm going to divide by 1.02 to the 20th power on both sides. Because I need P to be by itself, so I'm going to divide by 1.02 to the 20th power. So in my calculator, I'm going to go 2200 divided by 1.02 raised to the 20th power. So our answer that we get is P is equal to $1,480.54. So if I want $2,200 in 5 years, I need to deposit $1,480 now. The other thing you can do, sometimes even this number inside is really ugly, so you can just go straight to dividing. So you could have typed in 2,200 divided by, in our parentheses, because we had this in parentheses, 1 plus 0.08 divided by 4, parentheses, raised to the 4 times 5 power. You could type it all in as it appears, because these parentheses down here are telling you that this whole thing is the denominator. Hit enter, and you'll get the exact same answer. So sometimes when that inside number is a little funky, you can just do 2,200 divided by this whole stuff over here to tell you what P is. Alright, now we need to look at this other equation. This other equation is when it's not money. This is just the things equation. Okay, it's plus or minus. It's going to be plus if it's growing. So if it's telling you that it's increasing, it grows or it increases. It's going to be the minus if it's decreasing. We also call that depreciate or decay. Okay, so depending on what we're talking about, it would be a different terminology that's used as you go. Same idea. A is your final amount. P is your initial amount. R is your rate as a decimal. And T is time. It may not always be years. Whatever the problem gives you, you're going to assume that's the units you want to use. So if we use an example of a problem like this, I'm going to just lay this on top. Okay, so this says a car depreciates about 15% each year. If a car was worth $35,000 in 2013, how much will it be worth in 6 years? So we're not talking about compounded money, so we're going to use this equation. So A is our final amount. We want to know how much it'll be worth, so we're looking for A. P is the initial amount. My car initially cost $35,000. So this is going to be my P value. Here, our car depreciates. So we're going to be using the minus sign. We're going to do 1 minus. So 1 minus R is going to be what we focus on. 15%, that's our rate. So R is going to be 0.15. Move your decimal place 2 times. 2013, we want 6 years later, so T is going to equal 6. So now we go through and we plug it all in. A is what we want to know. 35,000 is what my car's value started at. I'm going to do 1 minus, since we're depreciating, we're going down, it's worth less, 0.15 raised to the 6th power. We're just going to type that in, 35,000, parentheses, 1 minus 0.15, close parentheses, you can't see that, raised to the 6th power. If we hit enter, that's going to tell us that 6 years later, so if you buy a car as a sophomore that's worth $35,000, when you graduate college, now your car is only worth $13,200.23. Okay, so because this was depreciation, we use a minus. If it said that it was something appreciates, we can add that word up here, appreciate. If it appreciates, it increases, something like that, then we would use the plus in our equation. It just kind of depends on what you're looking at.